So I'm just going to go over the Thermo quiz because we are working on the retakes and reviewing for the final. So I thought I'd record a video just to kind of go over the quiz because there will be some questions on the final having to do with thermochemistry. So question number 1, when absorbing the same quantity of heat, which of the following would change the temperature by the greatest amount? So you have all of these substances. So of course you're going to be looking at the one that's going to have the smallest specific heat. That means it's going to absorb the least amount of heat and then the temperature is going to go up. So that is why the answer is gold here, because it has the smallest specific heat in this list here. So that means it's only going to absorb 0.13 joules of heat before you start to see an increase in temperature. So that is what specific heat actually means. Number 2, this one again is a major concept. We didn't spend a huge amount of time, but remember my example of the boiling water. I had the probe in there and it didn't change. It kind of just flattened out. So when we are changing phases, the temperature stays the same. Heat involved in chemical reaction is a negative sign. That means heat is lost to the surroundings. Number 4, the amount of heat required to change the temperature of 1 gram of an object by exactly 1 degree Celsius is the specific heat capacity of that substance, while the amount of heat required to change the temperature of 1 gram of pure water exactly 1 degree Celsius is going to be 1 calorie. Okay, so that's the definition of a calorie. So those definitions you definitely need to know. So for the calculation portion here, I'm going to switch my camera occasionally and show you the correct answers. So for number 6, how much heat did the titanium metal transfer to the tap water, rounding to the hundredths place? So I'm going to kind of switch my camera here. So I took my titanium metal, I have 8.06 grams, I have the specific heat, and then I had how much did the titanium metal change. So it ended up being 34 degrees, and then I started with a temperature of 99.7, so the difference there is 65.7. Now you could write this as a negative joule, or you could write it as a positive. Again, the negative is just meaning the metal is losing. Again, it is negative because the final temperature is lower than the initial temperature. So back to the quiz. How much heat did the tap water in the calorimeter gain? Explain your answer. So key word there is explain. So realize it's the same as the titanium metal because it transferred all of its heat to the water. And yes, we're losing heat through this process, but we are assuming the heat gained by the water is coming from the heat lost by the metal. We're going to set those two equal. So that's why it says explain your answer for number 7. And then for number 8, how many grams of tap water were in the calorimeter? So again, the calculation itself, I had to take the joules I got from the previous problem, and then my X in this case is going to be the mass of the water. So I have the specific heat of water is 4.18, and the water temperature change was 34 was the final temperature, and 32 was the initial temperature. So that's a 2-degree change. So you end up about 34.2 grams of water in that particular case. All right. So to the last problem, okay, find the temperature of the oven. So this is where we had a nail in an oven for a period of time, it heated up, and then you dumped it into a certain amount of water. So of course you have enough information about the water to solve for the water's heat, and then you use that heat to find the temperature of the oven, So again, the heat of the water is going to be 345 grams times the specific heat. And then how much did the water change? So the final temperature of the water is 28.4 minus the initial temperature. So I get around 10,383 joules. And again, rounding is always going to be an issue. So I have to set that equal to what I call my nail. So 18.5 grams was the mass of the nail. I know my nail was made of iron, so my specific heat is 0.45. And my final temperature is 29.4, but I need to know what the initial temperature was. So I'm going to set this all negative on the outside because I know my initial temperature is going to be larger than my final temperature. So that might have been where the calculation went awry. So I set this all equal. I multiply these two to get this. I divide this to get around 1247.2 is equal to negative 28.4 minus x. So again, I distribute the negative, and there's many different ways you could do this algebraically. I just did it this way. So this became negative 28.4, and this became a positive x. So then I add 28.4 to both sides, and I end up with about 1275.6 degrees Celsius. And again, as long as your number was close to my number, I gave you full credit. I gave you full credit. So again, thermochemistry is on the final, so I thought it wouldn't be bad to kind of go through these questions with you. So that's all I have.